Our third lesson here in Unit 1 deals with evaluating and graphing piecewise defined functions. In our second lesson, we looked at graphing linear functions, linear absolute value, quadratic, and exponential. So piecewise is the kind of the fifth function family we're going to look at here in this unit. The nice thing about graphing piecewise functions is that if you can graph the other function families that we've looked at, you will see that their parts are what make up our piecewise defined function. So really there isn't a whole lot that's new about graphing piecewise functions, except for what's called a restricted domain. In order to make sure we navigate the restricted domain part correctly, we are going to go ahead and walk through here this number 1, which is evaluating a piecewise function. I'm going to do 2 modeling kind of what the thought process is, and then my recommendation is that you pause the video, try the next 2 on your own, and then restart the video when you're ready to check, or if you get stuck. That way you can hear the explanation of how they are done. Okay, so here we go. A piecewise function is defined on a sequence of intervals. Given the piecewise function, evaluate each of the following. So go ahead and take a look at this piecewise function that we have here. What are some of the things you see? What are some of the function families that you see within this piecewise? Okay, and hopefully we're connecting that this top function family here is a quadratic, and this bottom function family here is a linear. My quadratic up here has a positive a, which tells me that the u of this quadratic will face upwards. And my slope in this linear has a negative, which tells me that my line will be decreasing. Over here, take a look at the intervals that they're telling us, and what are some connections that you're making here. Okay, with this x is less than 3, what I'm hoping we connect are 2 things. First of all, that the only values that work for this entire top function are ones where x is less than 3. The other thing I'm wanting to make sure we recognize is that because there's no equals, this value here, if I were graphing it, would be a whole, right? Equals would imply that there was a point there. We talked about that in our first lesson of this unit. Okay, now take a look at the second one. Here, my x values are going to be greater than 3 or potentially equal to 3. That would work for this bottom function. The other thing I'm wanting to make sure we focus on is that because there is an equals, if we were to graph this function, there would actually be a coordinate point at x equals 3. Okay, and so here we go. To evaluate simply means to plug in. We just need to make sure we're careful where we plug in. So f of 0, x equals 0, which one of these inequalities would 0 work with? Well, it would work with the top one because 0 is less than 3. That tells me that I'm going to be plugging 0 into this top function. Okay, so here we go. 2 times 0 squared plus 1. 0 squared is 0, so we're 2 times 0 plus 1. 2 times 0 is 0, and 0 plus 1 is 1, so f of 0 is 1. Okay, it's going to be the same thought process, or I should say a similar thought process for b here. 5, we have to ask ourselves, well, which one of these inequalities would 5 work best with? In this case, we're looking at the bottom one. 5 is greater than or equal to 3, and so I know I'm going to be plugging this 5 into the 3. Or I should not say into the 3, into the bottom function, right? And so I'm going to go ahead and do negative 4 times 5 minus 2. Negative 4 times 5 is negative 20, and negative 20 minus 2 is negative 22. Okay? And so go ahead and pause the video, give those next 2 a shot, restart it when you're ready to check your answers or when you get stuck. Okay, so here we go. C, f of 3, which one am I plugging into? Well, x equals 3 would work with this bottom inequality, right? X is greater than or equal to 3. And so I'm going to be plugging 3 into the bottom function. Negative 4 times 3 minus 2. Negative 4 times 3 is negative 12, and negative 12 minus 2 is negative 14. Okay. And then last one, negative 2. Which one does negative 2 work with? Negative 2 is less than 3, so I'm plugging it into the top one. Okay, we have 2 times negative 2 quantity squared plus 1. Negative 2 squared is 4. 2 times 4 is 8. And 8 plus 1 is 9. And so f of negative 2 is 9. Okay, and so that's what it's going to look like to evaluate a piecewise function. So now we're going to get into graphing. Graphing with a domain restriction, which is part of what we will see within many of our piecewise functions. It means considering only the indicated portion of the domain of the function. And so for our next 5 examples here, we're going to go ahead and graph and then state the domain and range in interval notation. Okay, so here we go. For f of x equals the absolute value of x minus 2 plus 1, we're going to graph that if if x is greater than 1 and x is less than or equal to 4. Okay? Now, before you do any graphing, you want to make sure you've processed a couple of things. First, make sure you very specifically take note of what function or functions, depending on what the case may be, that you are going to be graphing. Make sure that you're thinking about what should I see on my graph at the end. In this case, this function is an absolute value, so I know it's going to be a v. I also have a positive slope in front of that absolute value, so I know my v is going to face upwards. The other thing you always want to make sure you take note of is that domain restriction, and whether or not the domain restriction shows that a hole will be there or a point will be there. Because one of the easiest mistakes to make with piecewise is going so quickly through the graphing because you know how to graph the function that you forget to be very careful about whether you should have a hole shown or a point shown. And so before we do any other graphing, we've already talked about the absolute value. Let's take a look at this domain restriction. X is greater than 1 or 1 is less than x. The fact that there is no equals tells me that this is going to be a hole. At x equals 1, I should make sure that I see a hole. And then over here at 4 being greater than or equal to x, or x being less than or equal to 4, tells me that there's going to be a point at x equals 4. And so as I graph, I'm going to make sure I remember that. A hole on x equals 1, a point on x equals 4, and I'm going to go no further than those two numerical values. Okay? And so here we go. We've done a lot of graphing with absolute value at this point, but let's go ahead and walk through it together. Turning this into our descriptive form, we have y, subtracting that 1 over to the other side. So y minus 1 equals the absolute value of x minus 2. I can now pull out my vertex, my hk. Remember that we're thinking either opposite or what makes this equal 0. Because again, that's why we are doing the opposite. We're looking for that shifted origin, right? Okay, well, so that means my x value will be positive 2, and my y value will be positive 1. Okay, x equals 2 is within my domain, so I can go ahead and plot that very confidently, 2, 1. If 2, 1 was outside of my domain, you might still very lightly put it onto your graph initially to help with the overall graph. Just make sure that you erase it at the end so that the only portion of the graph that's actually shown is what takes place between x equals 1 and x equals 4. But again, 2 1's in that interval, so we're good to go. My slope is 1, so I know I'm going up 1 over 1. Okay. So up 1 over 1, we're at x equals 3. My next up 1 over 1 is going to put me at x equals 4, which we said earlier was a point. So I'm going to go ahead and put a point there. And I'm done with that side. If I go up 1 over 1 in the other direction, I'm already at x equals 1. And remember we said x equals 1 was a hole. So I'm going to put a hole there. And I've got the other side of my absolute value. Okay? And so that's what it means to graph with a domain restriction. Stating our domain and range then. It's a little review from our first lesson of this unit. Domain, remember, are x values, range is y values. So domain, as I'm looking for the smallest x that I hit within this graph, the smallest x that I see is at x equals 1, and there's a hole. So I'm going to do a parenthesis. And then working my way across, I'm looking for any issues, holes, holes, breaks in the graph, asymptotes, that kind of thing. But there's nothing. X keeps happening all the way over to x equals 4, which there is a point at x equals 4, so I'm going to go ahead and do a bracket. Okay. Range our y values. The smallest y value I see on this graph is at y equals 1, and there is a point there, so that's a bracket. And then I'm going to work my way upwards, looking for holes, asymptotes, breaks in the graph. I do see a hole here at y equals 2, but I don't have to break my interval because over here we have a point that is located at y equals 2. And so because we do have something at y equals 2, it just happens to be located over here instead of here, we are able to keep going. So I have y's all the way up until y equals 3. And that's where my graph stops moving upwards. There is a point there, and so that's a bracket. Okay? Okay, next one. For f of x equals 2 to the x minus 3 if x is less than or equal to 3. So again, kind of one more time, the two things you want to make sure you take note of. What type of function are you looking at? What should it look like on your graph? And then your domain restriction. Do we have holes or points? And what type of x values are we going to be considering? Okay, so function first. This is exponential. So I know I'm going to have an asymptote. I'm thinking about that already. I should see a smooth curve. My domain restriction, we're dealing with values that are less than or equal to 3. And because we have that equals to, I know I'm going to have a point at x equals 3. Okay, so here we go. Descriptive form. Add that 3 over to the other side. We can now pull out our HK. My x is going to be 0. My y is going to be -3. Remember with exponential that is your asymptote that you have just found, not actually a point on your exponential function. Okay, so there's my asymptote. Now I need at least 2 other points. We talked about a lot in our second lesson, kind of what 2 points are advantageous. I'm going to throw in one more thought process for picking those 2 points right now. The first one I'm going to remind you of is that I tend to always recommend you plug in this x value, this 0, because it's a good place to start. So if we took our 0 and plugged it into our function, f of 0 equals 2 to the 0 minus 3. 2 to the 0 is 1 minus 3, and so f of 0 is -2. And so I've got a point there. And then we talked about the fact, or I made the recommendation that you, in picking your second point, that you stay pretty close to 0, you know, picking 1 or -1, and we looked at different reasons why you might pick either. But I'm going to throw in one more idea here. You can still pick 1 or -1, but remember that my exponential isn't going to go on indefinitely anymore. Because of this domain restriction, I'm going to end at 3. Meaning I'm going to recommend that you plug in that 3. You need to know where you're stopping, right? If you really wanted to, you could plug in each value. If you plug in x equals 1, you're going to get -1. If you plug in x equals 2, you're going to get 1. But I would recommend plugging in 3 so that you know exactly where you are ending. 2 to the 3rd minus 3. 2 to the 3rd is 8, minus 3 is 5. And so my final point here, and it is a point, remember, because we have equals, is at 3, 5. And with that, you've got your exponential. And it stops there, but we still have an arrow going to the left. Okay, let's go ahead and do one more together here. So now we're going to have 2 parts. Our piecewise function here is made up of 2 functions. So we've got our exponential on top. So I know I'm going to be looking for an asymptote and a smooth curve. Down below I have an absolute value, so I know it's going to be a V shape, and I have a negative slope. So where's that V facing? Down. Okay, so I want to make sure that I do consider that as I'm graphing. Okay, I also have over here with my domain restrictions, on top we have x is greater than or equal to -1, so I know I am going to have a point at -1 for that exponential, and all the bigger thans and equal to. And then down below we have our less than -1, and so this one's going to be a whole. Okay, and so then going ahead and graphing this, I tend to recommend giving yourself a little partition in your work, that way you can handle one function on one side, one function on the other. I tend to like handling the function that I view as a little bit easier to graph initially, and sometimes you look at the functions and they all seem about equal, but as I look at these two, I have a preference or leaning more towards the absolute value. So my recommendation would be to graph that first. If you're sitting there looking at both of them going, I don't care, then graph whichever one you want, it's not going to matter, but I'm going to start with this absolute value. So subtracting the 3 to the other side for descriptive form, we have y minus 3 equals -2 absolute value of x plus 2. My hk, my vertex, is that x is -2, y is positive 3. X equals -2 is within that domain restriction for my absolute value, so I'm gonna plot it confidently. Again, remember, if it wasn't, you could still put it on your graph initially, just do it really lightly to help with your overall sketch, and then erase whatever doesn't lie within this domain of less than -1. Okay? But we've got our vertex. My slope is -2, so I'm going to go down 2 over 1, and actually, if I go down 2 over 1, I'm already at x equals -1, and remember that needed to be a whole. And so I'm done on the one side. Going the other way, I have a lot more of the graph, down 2 over 1, and so I've got this side of the piecewise. Okay? Exponential next. There's nothing to subtract over, so we just have y equals, or add over, y equals 3 to the x plus 1. Okay, so my hk, x is going to be -1, y is going to be 0. Remember that that is my asymptote, so at -1, 0, I'm going to have a little asymptote there for my exponential function, right? Absolute values don't have an asymptote, but exponentials do. Okay, and then I've got to plug in some points. This might be where you choose exactly what you're plugging in, but my recommendation again is to plug in -1, and it's safe still to plug in the -1 because -1 is part of that restricted domain. Again, one more time, it is okay for you to plug in values that are outside of the domain, just make sure that they don't end up actually graphed permanently on your graph. But if they help with the overall shape of your graph, that's fine. 3 to the -1 plus 1, plugging in x equals -1, which is 3 to the 0 or 1. So when x is -1, y is 1. Which, look at that, when x is -1, y is 1, what that does is that plugs the hole that my absolute value had originally left. They happen to be at the same location. That won't always happen. Sometimes the hole will stay a hole. Just in this case, they happen to line up. Okay? And then you're going to be looking for, well, what else do you want to plug in? I'm going to go ahead and plug in 0 as my other value here. 0 is also within my domain, so I know I can plot it confidently. So 3 to the 0 plus 1, which is 3 to the 1 or 3. So when x equals 0, y is 3. Okay, and with that, I can sketch my exponential. Now, I'm not going to sketch what happened out here, because remember, my domain is greater than or equal to -1. I'm going to start here at equal to -1, and I'm going to go ahead and sketch upwards. And there's my piecewise. Okay, domain and range. And I just realized I didn't do domain and range on example 3, so after we do domain and range here on example 4, I'll go back and do that on example 3. Domain and range. Okay, domain are x values, so as I look at this graph, I've got my smallest x. There's an arrow here is telling me this graph keeps going. And it keeps going down and to the left, so my smallest x is going to be somewhere way out here, and then my smallest y is going to be somewhere way down here. Thanks to that arrow, so my smallest x is negative infinity. And as I work my way over, I've got something at each x value all the way to infinity. Because again, I have an arrow on this side telling me that this graph keeps going right all the way to x equals infinity. Okay, range is y values. We already talked about the fact that we have a negative infinity as our lowest y value, because this arrow tells me I'm going to keep going down. And I've got y values, continue to have y values all the way up to infinity. Okay. Okay, coming back up to example 3, domain and range. Okay, domain, x value is the smallest x value I hit because this has an arrow. I know I'm going to keep going left for forever, so it's negative infinity. And then I've got x values all the way to this point where my graph stops, which is at x equals 3. Because I have a point there, this is going to be a bracket. Okay, range, the smallest y value that I see is down here at y equals negative 3. And because that's an asymptote, I don't actually have a point at y equals negative 3, so this is going to be a parenthesis. And then I work my way upwards. I've got something all the way to this point where the graph stops, which is at y equals 5. And because I have a point there, this is going to be a bracket. Okay, so at this point you've seen me walk through 3 of them. There are 2 more piecewise functions, examples 5 and 6. My recommendation is to pause the video, give them a shot on your own, and then restart the video when you are either stuck and need a little helpful hint, or when you are ready to check your answer. Okay, so go ahead and pause the video now if you're going to. Okay, here we go. Example 5, we have 2 functions that we are looking at. The upper function is a quadratic, so I know it's going to be a u, and I see that I have a negative a, so that u is going to face down. And then I have 4, which we looked at our special cases, or I should say we reminded ourselves of our special linear cases on our second lesson. And so y equals 4 is going to be a horizontal line. For my inequalities, for this quadratic, I'm looking at all values of x that are bigger than 1. There's no equals, so that is going to be a whole. Okay. Down below, for my horizontal line, I'm looking for values between negative 3 and 1. There is no equals at 1, so that's going to be a whole. There is an equals at negative 3, and so that is going to be a point. The other thing that stands out to me as I look at these inequalities, there's nothing for x being less than negative 3. My graph is actually going to stop at x equals negative 3. It's going to go no further left. Okay, and so here we go. I'm still going to do my little partition even though there's not a whole lot involved with the y equals 4. Again, I mentioned on the last problem, I usually gravitate towards graphing what I view as the easier function first, but again, it doesn't actually matter what order you graph them in, so pick whatever order you want. But I'm going to graph that y equals 4 first, because I know that's just a horizontal line. At x equals negative 3, I know I'm going to have a point. 3, 4. And at x equals 1, I know I'm going to have a whole. And then there's my horizontal line. Okay. For my quadratic, I've got nothing to add or subtract over here to turn it into descriptive form, so I'm good there. My vertex, or my HK, my x is going to be positive 3, my y is going to be 0. X equals 3 is within this domain, so I'm going to plot that strongly, because I know it's definitely part of my graph. And then quadratics, remember, don't have a slope because they're curved. So we're thinking a over 1. My a in this case is negative 1/3, so we're negative 1/3 over 1, which means down 1/3 over 1. Remember that that pattern does not keep going. We don't go down 1/3 over 1 again, right? It's quadratic. It's not a consistent slope. I do need to figure out where I end though, because look at what my last value, a whole, needs to be for my quadratic. Okay, and so this is where it's going to be helpful to plug in this 1 to see where my ending point is going to be. So I'm going to go ahead and do that, plugging in 1. Okay, we have 1 minus 3, which is negative 2. Negative 2 squared is 4, and negative 1/3 times 4 is negative 4/3. And so I know I'm going to have a whole at x equals 1, y equals negative 4/3. And with that, I've got my quadratic here. And there's your piecewise function. Okay. And then domain and range. Domain, we are looking at our x values. Range, we are looking at our y values. Domain, the smallest x I hit is out here at x equals negative 3. And there is a point there, so that's going to be a bracket. And then I'm going to work my way over, and right here at x equals 1, I have no coordinate point. I have 2 holes, so I do need to cut it at 1. There's going to be a parenthesis because there's a hole. But while it stops at 1, it also picks right back up again at 1. So I'm going to have another parenthesis 1. And it keeps on going, and this arrow shows me that my graph is going to continue to keep going right for all infinity. Okay. Range, my smallest y value, because of this arrow, this is going down indefinitely. My smallest y value is negative infinity. And it keeps going up all the way to that point. And then I have a little space in my graph here. Right, everything in this region is space, so I need to make sure I cut off my range. And so my range is going to stop there at 0. And there is a point, so that's a bracket. And then my range does not pick up again until y equals 4. And then ironically, it stops again at 4. So this goes from 4 to 4. And that's my range. Okay, so last one. We have 3 functions now. 5, 2x plus 1, and 1/2 to the x minus 2. So I'm going to give myself 3 partitions. Okay. So first up, we have y equals 5. Looking at my restricted domains, I see that this one is just going to be for values less than negative 3, meaning that's a whole. For my linear, I have less than or equal to, so that's going to be a point. And then less than or equal to, that's going to be a point. And for my exponential, we have just less than, no equal to, so that's a whole. And just less than, no equal to, so that's a whole. So for y equals 5 here, we're looking at all values less than negative 3, where negative 3 will be a whole. So here we go, negative 3, y for my horizontal line, 3, 4, 5, that's a whole. And we're looking at all values less than negative 3. Okay, linear is up next. We have descriptive form, subtracting that 1 to the other side. Y minus 1 equals 2x. My HK, my starting point, x is going to be 0, y is going to be positive 1. X equals 0 is within this restricted domain for my linear, so I'm going to plot it confidently. And I know I'm going to have a point on either side, a point at x equals 1, a point at x equals negative 3. So as I now move my slope of 2 up 2 over 1, I'm going to keep going till I hit 1 and negative 3. So up 2 over 1, I've hit x equals 1. And down 2 left 1, down 2 left 1, down 2 left 1. I just hit x equals negative 3, and so I'm done. Okay. And last but not least, we have our exponential. Adding this 2 over for descriptive form, y plus 2 equals 1/2 to the x. My HK, x is going to be 0, y is going to be negative 2. That's my asymptote, so 0, negative 2. Okay, plotting your points. My recommendation has always been to plug in 0. You still can, but make sure you are careful. This is what I keep referencing. X equals 0 is not within this domain. And so if you plug in 0, you will get something that's outside the domain, so you will have to plot that very lightly, knowing that you will need to erase it before you are done, because the only thing that can actually exist on my graph for this exponential is what happens between 1 and 2, and there need to be holes at both x equals 1 and x equals 2. The other thing you could do is, because we are just looking from 1 to 2, is you could make those the 2 points that you plug into your function. There isn't one that's necessarily better. I like plugging in 1 and 2 just because that's the little piece of the graph that's actually going to exist. Just make sure that you're careful that this is the only thing that remains at the end of your graphing. Okay, so I'm going to go ahead and plug in 1 and 2. Okay, so if I plug in 1, let me switch colors here, sorry, quick bit. Okay, if I plug in 1, we have y equals 1/2 to the 1 minus 2, which is 1/2 minus 2, and then for those who prefer fractions, that's negative 1.5. For those who prefer, for those who prefer decimals, it's negative 1.5. For those who prefer fractions, it's negative 3/2. And so I know I have a hole at x equals 1, y equals negative 3/2, or negative 1.5. Okay. And then I'm going to go ahead and plug in 2, so we have y equals 1/2 to the 2 minus 2, which is 1/4 minus 2, or for those who prefer decimals, negative 1.75. For those who prefer fractions, we're looking at negative 7/4. Since I did a fraction here, let me go ahead and do a decimal down here. So negative 1.75. And so I know I have a hole at x equals 2, y equals negative 1.75. And so I just got this little itty-bitty piece of an exponential down there. Okay, domain and range. Domain and range. Domain for this one, what's the smallest x value I hit? Because of this arrow, I know I go infinitely left, so the smallest x value I hit is negative infinity. And then I work my way to the right, looking for issues. Uh-oh, I've got a hole here at x equals negative 3, but I've got a point down here, and it keeps going, so I'm good to go. Still have x values, still have x values. Uh-oh, break in the graph, but It picked up again immediately right here, so I'm good to keep going, and my graph stopped at x equals 2. Excuse me. There is no point at x equals 2, so that is a parenthesis. Okay, range. Range, the smallest y value I hit is down here at y equals negative 1, 2, 3, 4, 5. And there's a point there, so that's a bracket. And then I'm going to work my way up looking for issues. I got some holes over here, but we have points on this graph to compensate, so I still have y values, so we're good to go. And then right here we've got a break again in my graph. So I need to make sure that I do cut off the range here at y equals 1, 2, 3. There is a point there, so that's a bracket. And then my range picks back up again up here at 5, and it goes from 5 to 5, and so that's my range. Okay, and that's your third lesson.